time you're using fourth or third. You know what time you use it. Like, in any situation we're using four.
Oh, I have a video for this. If you go to the lecture notes for that day, on the website, it's like a 10-minute video, and it made sense. That master.
They're all different.
Oh, you know. Is it the
Maybe that one.
Mellow me out. Yeah, that's like exactly what I want.
waves?
Maybe. Yeah.
Oh, thanks.
No, I'm on Tinder.
You're on Tinder?
No, I'm not on Tinder.
Oh my god. So I took out all the words in my Tinder profile and I put, I'm just looking for people to play Pokemon Go with. I got 5 matches.
So, all right,
Yeah.
hello. Helen, before we get going tonight, Helen is here to talk about the physics club, okay? So if you could listen to him and at least be aware of what's out there.
So Physics Club is meeting over the summer at 11:30 a.m. on Thursdays in P144. And I brought donuts last week. I'll bring donuts again this week. It's a good way to get a little bit of extra exposure to topics and for if you're just not 100% comfortable with them. 3 of the members have been in since last quarter, since fall quarter, have all been through the full physics series. And so we've got a fair amount of experience with it. Last quarter we tried to make an electromagnetic can pressure to just run a bunch of current through some coils with an empty can in the middle of that. And the idea was that all that changing current would induce would induce a magnetic field, which would then induce a current in the can itself, and that current would cause an inward force and crumple it. What happened when we first tried to set it to do that was the coil itself collapsed and arced, and then the relay exploded. I guess there was a big firewall. I wasn't there when they tested it, so there's opportunities for big fireballs. I'm also going to try and get hopefully something summer quarter as far as field trips go, but at some point a trip to LEGO maybe, hopefully the Boeing Air and Space Museum and other things like that. And one of the members is not here during the summer quarter, but he'll be back in the fall, and he's been working in the tutor center as a physics tutor. And again, we're also pretty well versed in the material, so that helped with that. And that's most of it. You don't have to be a physics major, obviously, to join the club. You don't have to be a physics student currently either, you know, there's anybody that's interested. And yeah, it's just, you can, if there's stuff you're interested in too, we can explore that, and it's a lot of stuff like that. You can, to a certain extent, contribute what you want to contribute, and we can explore
if you don't mind, I've seen a lot of the physics club demonstrations and been somewhat involved with physics club for, gosh, maybe like 7 or 8 years. And I see 3 reasons for joining the physics club, okay? One of them is to play with fun stuff, okay? That if you are thinking, you know, I really want to work with high voltages, I want to work with high temperatures, I want to do this safely and have fun, there are people that will encourage you to do this and get excited about it with you, okay? So that's fun. Another thing is help with physics. There are these people are interested in physics. They also want to pass their classes. If you were thinking, you know, where do I find somebody who knows about this stuff and isn't another instructor, the physics club is a good place, okay? And in general, people in the physics club are very nice, okay? So no, I'm serious, you're laughing, but they are. They are, you're nice people, okay? And so if you're worried about, you know, guys are gonna be intimidating and stuff like that, they're not like that, okay? So they're good for, physics club is good for that sort of thing. The other thing that it's really good for is your resume. If you can get involved with research projects and things that you can write down and you can say, I was involved with this research that published this paper, and although I wasn't a primary researcher, I helped collect this data, or I was involved with this project and I understand how it works.
Yep. Student
Cool.
leadership stuff always looks good.
Yeah, so, yeah, there's a lot of good stuff like that.
And if you guys want to be on mailing list, I'll put my email up in the corner here.
Do you have meeting times?
Yes.
Oh, you want to put those up there?
And let's see, hoping to get the cam pressure working this quarter, which would be free. There's a few different things you can do with the coils too. You can make it, if you have 2 magnets or 2 electromagnets instead of 1 facing opposite directions, then you can make the can split and shoot out. So that's a possibility. So I'll let you get to teaching and get to my chemistry class.
No, we are, okay,
Yep.
thank you.
Thank you.
I will also add that I think this is the first time the physics club has been active during the summer. So that is really cool. It's growing. If you decide, you know, my summer's really busy, I'm sure they'll be active in the fall, and this would be a good, if you wanted to say, I can't really do this right now, but in the fall, I want to try and get involved. I'm sure you'd welcome that as well. Cool? Okay. Let's start off by talking about things that are due and things that happened over the weekend. There is a homework assignment that's due today, and we also have our first exam tomorrow. My plan for tonight is, I will write this out. Present a little bit of new material. Okay. So really, well, a little bit of new material. Then review for the exam. And then we have an in-class problem. okay? So that's Monday today, okay? On Tuesday, tomorrow, we have the exam. The exam, the format is the same as the ones that are posted online on Canvas, okay? So if you go, yeah, what's it gonna look like? It's gonna look like that. The questions will all be different, but I'll have some multiple choice stuff, some skills stuff and things like that. So if you haven't already taken a look at it, I would suggest you take a look at it. For the format, not for answering all the questions. Don't get too worried about, oh, I gotta be able to answer exactly this, because I'm asking you different stuff, okay? I think that if you were right on when you were taking the exam, that you didn't go down any false starts, you could finish in an hour. Nobody does though, because everybody makes a few false starts and has to think about something, goes, oh no, it's like this. So I'm giving you 2 hours to do it. That's what I normally do. Although we got a 3.5 hour class period. So I think what I'm going to do, I know what I'm going to do. I'm going to, sorry. I didn't want you to think that there was going to be okay. What I'm going to do is, class will start at 5:30. And we can talk about whatever. Okay, and then at 6:30 we'll start the exam. And at 8:30 it'll be done. Okay, so here's what I'm thinking. We've got a little bit of new material. Some of it will be on the exam. Most of it actually won't, and I'll talk about why in a bit. I'll review for the exam, so that'll be helping us get ready for the exam. We'll do this in class problem. That'll all be good, okay? But you're gonna go home, you're gonna finish up the homework, you'll look at the homework solutions, will automatically come online at midnight. So tomorrow you might look at the solutions and be thinking about things and studying, and you might have questions. So if you come in at 5:30, okay, you can ask questions, and I will talk about whatever between 5:30 and 6:30. Okay, I'll try and keep the topic on exam stuff, but if we run out of other things to talk about, I don't care. Okay, and then we'll get to 6:30, and I'll hand out the exam, and we'll do it. Good. I suppose for exam days only, if you really decide I don't have any questions, you can show up at 6:30. Okay, I promise you, I won't start before 6:30. Okay, but I want to use this hour to sort of answer questions, so feel free to take advantage of that. Is that clear? And good? Seem okay? All right. So good. Oh man, did I mess that word up? Present. I knew I missed an S, but I missed more. Okay, present a little bit of new material. So let's do that. We talked about superposition. We talked about how when you have a wave and it encounters another wave, that you would add the amplitudes at the location, and that superposition can cause the waves to either to appear amplified or to cancel each other out. Okay, so that sort of thing is called interference. Okay, and it's when multiple waves affect each other. Well, or let's say combine. With superposition. Okay. And in general, there are, well, in general, it can be kind of complicated. You could have a complex waveform, encounter some other complex waveform, and you do superposition and you see what you get. But often you can sort of simplify it. And you can say that one type of interference that commonly occurs is called constructive interference. Okay. And that's when sort of the peaks and valleys line up so peaks are on peaks, peaks match peaks, and valleys match valleys. Okay. So this might be a situation where we have a wave that's going like this. Okay. And another one that's going like this. Okay. So as we look at, well, how would these combine and how would the superposition work? I have a peak and a peak right lined up with each other. So the net result would be a big tall peak, right? It would, and over here I have a valley and they're lined up with each other. So the net result would be a big valley. This would look something like this, and it'd be extra tall, extra deep, extra tall, extra deep, extra tall, extra deep, like that. It's sort of, anyway, something like that. Okay. Sometimes we have destructive interference. Okay. In that case, the peaks line up with valleys. Okay, so instead of having the peak next, if these are your two incoming waves and you want to know their net result, okay, one of them might have look like that, okay, and the other one looks like this. So when this one's at a peak, that one's at a valley, okay? When this one's in between below, this is in between below. When this is at this red one's at a peak, that one's at a valley. If these were both coming in on top of each other, they would cancel each other out, right? If I take, one little part here and one little part here and add them together, well, all the way through this, I end up with nothing being there. So even though I've got these two waves, okay, I end up with no net result. Okay. Okay, so those are constructive and destructive interference. There are a number of ways to get that to happen. Okay. One of them is a phenomena called beats. Okay, and that's when one of the waves is slightly different, slightly different frequency. Okay, so over here, I have these little rods that I can thump. Yeah, can thump them like this, and you can hear them vibrate, okay? This one is tuned so that it vibrates, it has a frequency of 440 cycles per second, okay? So when I thump on this, I get this waveform that goes 440 times a second. Okay? This one is 441, okay? So it's slightly faster than the 440, right? I mean, I hit that one a little harder, but it sounds about the same, okay? But they're off by just a little bit, okay? So if this one in 1 second does 440 cycles and this one does 441, that means every second they switch over from being being very close to in phase with each other. So they're pretty close to this, maybe say the red one's a little bit faster, okay? And over time, instead of having these exactly match up, because the red one's occurring a little more frequently, it begins to shift over a little bit like this. And after half a second, it would look like this, right? So, and then half a second later, it would look back like that. And so it would go in between, okay? So what happens is if I play one or the other, they sound about the same, right? They sound somewhere around 440 cycles per second. But if I play both of them together, what we'll hear is them going alternately between constructive and destructive interference at 1 cycle per second, right? Because after 1 cycle, it switches through both of those, okay? So, I should do that. I'm going to bring this towards the center of the room so it'll be easier to hear, and I'll hit them hard, but you may want to get closer so you can hear it. Maybe I should have 2 mallets here, but so what you may be able to hear now is sort of a wah, 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 okay? And you might think, that's just my ears doing funny stuff, but it's not. It's the beats, it's the fact that one of them is alternating between constructive and destructive interference. Do you hear that sort of, yeah, okay, good, okay. So that's how this works, okay? You might go, it didn't completely cancel out, why not? Too fast? Well, not necessarily too fast. Well, they are switching back and forth, okay? One of the things is, I probably didn't hit them both with exactly the same intensity. So in addition to them being slightly alternating in and out, one of them is probably louder than another because I hit it harder, right? Okay. So yeah, that's just I can't hit them exactly the same, okay? But you can still hear this sort of partial beat thing, and they'll partially cancel out and then partially constructively interfere. Okay, cool. That's it for new stuff that would be on the exam. Okay, so I have one more topic that I want to get to tonight, and actually that I want to play with, that's going to become incredibly big and sort of the basis of the next chapter. And your book introduces it in this chapter, doesn't do a lot with it, okay, but then the next chapter you do a ton with it, okay, and I can kind of understand the educational advantage of this, is that you get some chance to sort of get it rattling around in your head before you have to use it a lot. Okay? So this second, I have to put those back here because the class over there is going to use them in an hour or so. Okay. So this next idea is that the interference might occur because you have the same signal that's playing, okay, but it's the sources are in different locations, okay. So one of the things your book talks about is suppose you have like a loudspeaker, right, and that loudspeaker is emitting some waves like this, right? Okay? And then you have another loudspeaker that's, say, behind it. Okay? And it's emitting the same waves, because they're both wired to the same signal, right? Okay? So whatever it's doing this, I'm going to do a different color. Okay, so it's doing the same signal. These have the same period, the same frequency, same amplitude, because they're the same signal. What would cause them to interfere constructively? Well, for constructive interference, we gotta get the peaks to line up with the peaks, right?
The distance equal to a multiple of the wavelength.
Yeah, so if the distance was a full wavelength, that would work, right? Because when this goes, well, right now, this isn't a full wavelength. A full wavelength is something like this, okay? Or say, something like that, okay? And these speakers are too close together. But if I slid this one back so that this peak occurred on top of that peak, okay, then I'd get constructive interference, right? Okay. Where I've got them right now, what do I have? Destructive interference. Okay. So we can say this distance here is d, okay, and we'll say this is a difference in path length. Okay. And so if this distance, if d, okay, if it's equal to a wavelength, it would have constructive interference. Is that the only case?
Any multiple
If
of
they're
the
the same.
wavelength.
Yeah, what if it were multiple wavelengths? Or, go ahead. Yeah?
Yeah, basically the same.
Yeah, yeah.
Oh, it's
So if it were one wavelength, it would constructively interfere, but also if it were two wavelengths or three wavelengths, right? So if we were to say, all right, we could say, all right, this is a path difference, okay, or difference in path length. If that difference is a multiple of the wavelength, okay, then we get destructive or constructive interference. So so what we can do is say if d equals m lambda, okay, where m is equal to, well, it might be 1, 2, 3. If we wanted to generalize this, does it matter which one's in front or which one's behind? No. So we could say plus or minus 1, plus or minus 2, plus or minus 3, right? Okay, because one could be in front and one could be in, and I don't know which one I'm gonna call in front or behind, but either way is allowed, okay? Is that it? What if they were on top of each other? What if the two speakers were just right side by side? Would that be constructive or destructive? Or nothing, or what? What if the difference in path length was 0?
Be constructive.
It'd be constructive, right? Because whatever one of them is doing, the other would be doing the same thing right on top of it, right? So this could be 0 as well. Cool? Okay. All right, so that's the condition for constructive interference. What about destructive interference?
Half of lambda is equal to any of them.
Okay, so you could say half of lambda, so D is equal to, well, half of lambda times m,
Yeah, half m times lambda.
half of m. Oh. I think this is the right idea, okay? But, meaning that you want them to be off by half a wavelength, but if we say, we'll allow any integer times a half, well, 1 times a half would give you a half, 2 times a half would give you 1, and 1 lambda would be back over here, okay? So really what you need is, you could say where m is an odd number, okay? Because the even numbers would just give you, 4 divided by 2 would give you 2, 6 divided by 2 would give you 3. So it would be somewhere back over here. So you could say, I need to have m is odd. The way your book does it is they say, well, m can be an integer, but what we'll do when we multiply something by lambda, we'll say m plus 1/2, okay, times lambda, okay? So m is an integer. It could be 0, it could be 1, it could be 2, it could be 3, it could be minus 1, minus 2, okay? But if you take an integer and add a half, you're always going to end up with something plus a half, right? So there'll always be a half a wavelength out of phase, and an integer number of wavelengths plus a half, or minus a half. So often we'll write it like that, where m is 0 plus or minus 1, plus or minus 2, and so forth. Cool? Okay. Now, you could line it up like this, okay, so that you have your 2 sources just all in a line, okay? Or for 2-dimensional and 3-dimensional waves, you could have your sources emitting the waves, and you could find patterns, okay, places where you have constructive or destructive interference. Okay? The in-class problem we will do tonight, what we'll do is we'll find the locations of the constructive and destructive interference for different situations, okay? And the way we'll do it is I'll have you each work on a slightly different problem and hand it in tonight. And then on Thursday, when we come and look at it again, we'll see the results and we'll talk about them in the context of the next chapter and where we're end up doing this a lot. Okay. Cool. So, all right. So this part about the path difference in length is not on the exam, okay? It should follow, it shouldn't be a big stretch from where we're going, and it sets us up for the next stuff that we're gonna do. But don't, as you're studying for the exam for tomorrow, don't focus on that. Good? Okay. I'm going to go ahead and review. Shall we take a 5-minute break and then come back and then I'll do a review, and then we'll take another 5-minute break and come back and we'll do the problem. Good?